Hello everyone. My concept is disintegration constant and half-life. Myself Yashwant H. Disintegration constant. The disintegration constant of a radioactive element is defined as the ratio of the number of atoms of the substances disintegrated in unit time to the number of the atoms of the substances present at the time of disintegration. Proportionality between the size of a population of radioactive atoms and the rate at which the population decreases because of a radioactive decay. Suppose n is the size of the population of radioactive atoms at a given time t, and dn is the amount by which the population decreases in time dt. Then the rate of change is given by the equation dn by dt equals minus lambda n, where lambda is the decay constant. Integration of this equation yields n is equal to n naught e minus lambda t, where n naught is the size of an initial population of radioactive atoms at time t is equal to 0. The population decays exponentially at a rate that depends on the decay constant. Half-life. Half-life. The symbol of half-life is T half, is the time required for a quantity or a substances to reduce to half of its initial value. The term is commonly used in nuclear physics to describe how quickly unstable atoms undergo radioactive decay or how long stable atoms survive. A half-life often describes the decay of discrete entities, such as radioactive atoms. For example, medical sciences refer to biological half-life of drugs and other chemicals in human body. Rutherford applied the principle of radioactive elements half-life in the study of age's determination of rocks by measuring the decay period of radium to lead-206. Half-life is defined in the term of probability. Half-life is the time required for exactly half of the entities to decay on average. In other words, the probability of a radioactive atom decaying within its half-life is 50%. The relationship between the half-life and the decay constant is given by T half equals 0.693 divided by lambda. There are many problems related to the half-life. Calculate the decay constant K of 32 phosphorus. The half-life of phosphorus 32 is 14 days. Half-life is given T half is equal to 14 days. Lambda equals K. T half or half-life is the formula of half-life is 0.693 divided by lambda, where lambda is the decay constant. T half is 0.693 K. K equals 0.693 divided by half-life time is 14, so divided by 14, which equals 0.495. So decay constant equals 0.495 per day, that is 0.021 per hour, or 0.00003 per minute, or 0.0000005 per second. The another problem is calculate the half-life of iodine 131. The decay constant K for iodine 131 is 0.0866 per day. T half equals 0.693 bar K. T half equals 0.693 divided by the value of K is given, that is 0.0866, which equals 8. So the half-life period or T half equals 8 days. All these contents are the reference of biophysical chemistry principles and techniques of the author is Upadhyay and Upadhyay Nath. Thank you.